So we have our little penguin family who wants to learn about rational expressions again. We're going to continue working on operations on rational expressions. So we've done reducing rational expressions, multiplying and dividing. Today we're going to focus on adding and subtracting. So in order to do that, let's first take a look at some rational numbers. Okay, so let's say, for example, that we have 3 over 4 plus 5 over 4. So in order to add or subtract these types of numbers, we must have a common denominator, okay? We're taking parts of a whole. So we're taking 3 out of 4 parts and we're adding it to 5 out of 4 parts. This is saying that we're dividing our whole into 4 parts. Okay, so what we're trying to do is we're trying to add parts that are of equal sizes together. So these 3 parts that we have here are all of equal sizes, and these 5 parts here are also all of equal sizes to this one. Okay, so these 3 and these 5 together are all equal sizes. That's because our denominator is the same. If our denominators were different, then we would be trying to add parts that weren't the same size, which would make the addition very difficult. Okay, so for example, if you're trying to figure out how many slices of pizza that you have, but you have a pie that has, you know, a radius of 15, and then you have a pie that has a radius of 30 inches, well, it's going to be really hard to determine how much pizza each person gets, okay? Because, and the reason for that is that the slices are of different sizes. So to determine what would be an equal amount of pizza for each person would be much more difficult, okay? That's kind of a long way of saying that we need this common denominator because we need to be adding sizes, at equal sized parts, okay? So here the common denominator already exists. We have a common denominator of 4. So we just add the numerators. And if we have 3 over 4 minus 5 over 4, what we're doing is exactly the same thing. We're saying we're subtracting sizes that are equal, you know, parts that of equal sizes, but we're subtracting. So we subtract the numerators. So all that the denominator does is it tells you the size of the part that you're subtracting, okay? But we really have 3 parts and 5 parts is 8 parts. We have 8 parts that have a size of 1/4. Here we have 3 parts, we're subtracting 5 of them. The size is the denominator, okay? So we need to subtract parts of equal sizes. So let's write this down as just general rule for addition and subtraction. So when adding and subtracting rational numbers or expressions, I'll put in parentheses parts of equal sizes. The numerator is the number of parts. The denominator would indicate the size of the piece. Okay, that's what's going on, which is why we're not adding or subtracting sizes, we're adding and subtracting number of parts, okay? So it's only the numerators and the denominators that get added or subtracted. Sorry, I said the numerators or the denominators. I meant it's only the numerators. So let's take an example, again, just of rational numbers. we'll come back to the rational expressions. Let's take an example where we don't have a common denominator. So like, for example, 3 over 2 plus 7 over 4. Now what this is saying is that we have parts that are different sizes. This has a size of 1/2, this has a size of 1/4. We can't add those together the way that they are because they are different sizes, okay? So what we need to do is we need to make these of equal size. So common denominator, we're looking for the least common multiple. And we've already done this, because when we were doing linear equations and we had fractions, we said let's get rid of the fraction. And the way that we do that is we find the least common multiple of all the denominators. So that's what we're doing here. So the common denominator is the least common multiple of the denominators. So here, we go to the larger denominator. Larger denominator is 4. 4 is a multiple of 2. So our question is, what do we need to multiply 2 by in order to get to a 4? Now this is actually a lot easier when we work with rational expressions because we don't need to know our multiplication tables that well. Here we have to know them a little bit better. This one is not that complicated though. We multiply 2 by 2 in order to get to 4. So we're multiplying both the top and the bottom by 2. We have to multiply both the top and the bottom so that we're not changing the value of the fraction. 2 over 2 is 1. We're doing 1 times 3 over 2. That's still 3 over 2, okay? We're just changing the way that the fraction is written. We're not changing its value. So now what this gives us is 6 over 4 plus 7 over 4. Or 13 over 4. Now remember, leave it as an improper fraction, but that's not really going to come up here that much because we're not adding or subtracting rational numbers. We're actually going to be working with expressions. Okay, so this is how we work with rational numbers. So let's take some examples of rational expressions and start doing that. So we're doing addition and subtraction of rational expressions here. Let's take an example. Let's start simple. Let's say that we have x over x plus 3 plus 3 over x plus 3. So the first thing that we're going to do is we're going to look at the denominators. The denominators already are common, so we don't have to do anything extra. So here we're just adding the numerators. And the denominator carries through, because remember, the denominator is just essentially the size of the pieces that we're adding. So we don't add sizes, okay? The sizes of the pieces aren't changing. We're just adding the number of the pieces, okay? So I'll put that in parentheses. If you don't watch the video and you just look at the board notes, this might be a little bit confusing to you. So unfortunately, but I'll put it in here so that if you did watch the video. So we'll say the denominator is the size of the pieces that you're adding. Or subtracting. And the number is and the numerator is the number of pieces. So you're adding numbers, you're not adding sizes. here this is saying that we have 3 pieces of size 4 or 1/4, 5 pieces of size 4. How many pieces do we have in total? We have 8 pieces of size 4. Here we have 3 pieces of size 4. We're subtracting 5 pieces of size 4. So now we have -2 pieces of that size. Here we have 3 pieces of size 2 plus 7 pieces of size 4. We're going to rewrite the 3/2 so that it's equivalent to the same size piece as this one. So we rewrite it as 6 pieces of size 4. That's what 3 pieces of size 2 is. So here we have x pieces of size x plus 3 plus 3 pieces of size x plus 3. The size of the pieces is already the same, so we're just adding the number of pieces. So x plus 3, we have x plus 3 over x plus 3. Always remember to reduce your fractions. Let's put that back in black. Okay, so this is equal to 1. That looks like a 7. It is not a 7. Okay, so this, we already had a common denominator. Added the numerators and reduced our answer. So let's take another example. Let's say that we have x over x squared minus y squared minus y over x squared minus y squared. Okay, we already have a common denominator, so we don't have to do anything extra here. The difference is that we're subtracting. So in our numerator here, we have an x minus y over x squared minus y squared. Okay, and we always look to see if we can reduce. Here we can reduce. X squared minus y squared is the difference of squares. So reducing here means that you have to factor like we did in the last lecture. The x minus y over x minus y cancels, and it becomes a 1. Okay, so remember, when everything cancels in the numerator, it just becomes a 1. This we factored into a difference of squares. We already had a common denominator. Let's take one more example like this. Let's say that we have 2x minus 3 over x minus 2 minus x minus 1 over x minus 2. Okay, so this is another case where we already have a common denominator. Okay, I'm going to actually rewrite this because it doesn't look like x minus 2. What's better? So because there's already a common denominator, we don't have to worry about finding a common denominator. But we're subtracting, and we're subtracting this whole numerator here. Remember that there are invisible parentheses around here. I'm going to put this in this color. So we distribute this minus. Okay, don't forget to distribute the negative. So now when we subtract, I'm going to put in an extra step here. You can skip this step. I'm going to put in what happens when we distribute that negative. So we have 2x minus 3 minus x plus 1. If you need to put this in so that you don't forget to distribute the negative, then please do. It's worth doing this extra step. And what we get is x minus 2 over x minus 2. And we already know that that's equal to 1. So don't forget to distribute the negative to that second fraction. It's just the second numerator. Remember, the bottom is just a size. Bottom has nothing to do with what we're adding and subtracting. The bottom just tells us what size pieces we're dealing with, okay? Okay, so let's talk about what happens when we don't have a common denominator, because all of this is great, but we kind of already know how to do all of this, because this is just addition and subtraction, and then this is just reducing. So it's really the practice that we haven't had is what happens when our denominators are not the same. And I'll emphasize again that this is the size of the pieces. So let's take some examples here. Let's say that we have, I'll number these examples. Let's say that we have 2x over x plus 3 plus 4 over x minus 5. So now our pieces are different sizes. We have a size of x plus 3 and a size of x minus 5. And we can't have pieces of different sizes. We can't add them that way, okay? So we need to make the sizes the same. And here's how we do that. We ask ourselves a really simple question. We go to each denominator and we say, what does the other denominator have that this one doesn't? That's our question. That's going to tell us what to multiply by. That shouldn't be a question mark. Okay. So we're looking at this denominator and we're going to look at the others, and there's only one, and we're saying, what does this have that this one doesn't? This one has an x minus 5. Remember, there are invisible parentheses, so the x minus 5 is together. You can't separate an x minus 5. So you can't say, well, this one has an x, but it doesn't have a minus 5. It's this whole group of things. Okay, the parentheses groups things together. The x minus 5 is a group. So what that means is that we have to multiply by the entire x minus 5. And if you remember, we multiply both the numerator and the denominator so that we're really multiplying by 1. So we're multiplying this by x minus 5 over x minus 5. Now we're going to do the same thing with this denominator. We're going to say, what does the other denominator have that this one doesn't? Well, the other denominator has an x plus 3, and this one doesn't have an x plus 3. So that's what we're going to multiply by. And remember, x plus 3 has the invisible parentheses. So this gets multiplied by x plus 3 over x plus 3. So I'm going to put in here that we multiply the numerator and the denominator by the same thing. So the whole fraction is being multiplied by 1. And we're not changing the value of anything. Okay, so meaning we're not changing any values. Okay, anything times 1 is itself. Okay, all we're doing here is we're changing the size of the pieces that we're adding. Okay, and if we change the size, that's going to change the number of pieces. Okay, if we divide a pizza into 4, okay, that's very different than if we divide a pizza into 8 pieces. You're going to get a different number of pieces if you're getting equal parts of the pizza. Okay, so here, our next step is to distribute. So if we distribute, then in the first fraction, we get 2x times x, which is 2x squared. And then minus 10x. And then our denominator is x minus 5 times x plus 3. So we have to distribute this 2x to the x minus 5. And then we have to do the same thing with this one. We have to distribute the 4 to the x plus 3. So we have 4x plus 12 over x minus 5 times x plus 3. And now this is just like before. All we're doing is we're adding. So when we add negative 10x and 4x, we get negative 6x. So let's put in that distribution. Okay. 4 gets distributed. That's how we get these values here, this 2x squared minus 10x and this 4x plus 12. Okay, so from here, we're almost done. We just have to make sure that we can't cancel anything. So we have to look and we have to see, can we factor this 2x squared minus 6x plus 12? And we can see here, you can, multiply a times c and try and factor this quadratic, but we can see that everything is divisible by 2. So I would start from there. I would start by just dividing everything by 2. Just because it might be easier to see whether or not something is factorable. Okay, so we're factoring to see if we can cancel anything. And it turns out that x squared minus 3x plus 6 is not even factorable. Okay, there is a shortcut here. You know that you would want to be canceling an x plus 3 or an x minus 5. So you can see, are any of these factors of x squared minus 3x plus 6? Okay, there are 2 ways to do that. You can use the remainder theorem. I'm not going to go over that here in any great detail. All I'll say is that if x plus 3 is a factor, then x equals negative 3 would be a root, so you could plug it in and see if you get 0. Okay, or you could just try to factor and say, are 3 or 5 factors of 6? If they are, is x plus 3. Can we multiply x plus 3 by anything in order to get x squared minus 3x plus 6? And it would have to be a 2, and x plus 3 times x plus 2, or x minus 2, when we add it together, we're not going to get a negative 3. If that didn't make any sense to you, don't worry about it. It's just a shortcut. So if it made a lot of sense, if you're really practiced in factoring, then that might have made sense to you in terms of a shortcut. But x squared minus 3x plus 6, not factorable. So you can leave it like this. You don't have to go any further. The only point of factoring here was to see if we could cancel, and we already see we can't. Okay, so we factored. The numerator to see if anything could cancel. But it can't, so there's nothing that we can do. So from here to here, I'm putting this in a different color, just so that it's easy to see. From here to here, all we did is we distributed. And then from this step to this step, all that we did was we added the numerators. And then we factored to see if we could reduce. Okay. So this is a 3-step process. We find the common denominator, we distribute, we add or subtract the numerators, and then we factor to see if we could cancel. Okay, let's take another one. Again, we're just going to do a bunch of these. So we have x plus 1 over x minus 6, or sorry, x plus 6 times x minus 2. And then plus x minus 3 over x plus 6 times x minus 1. So remember what our question is. What does the other denominator have that this one doesn't? So we go look at the other denominator. The other denominator does have an x plus 6, okay? It has an x plus 6, but this one has an x plus 6 also. So we don't need to multiply that because this one has it. We look at the other denominator, it has an x minus 1. This one does not have an x minus 1. So we're just gonna, that's what we multiply by, okay? So that's what we mean by lowest common denominator, is that we're only multiplying by what this denominator doesn't already have. So it doesn't already have an x minus 1, that's what we multiply by. And remember, what you do on top, you have to do on bottom so that we don't change the value. Now we're going to work the other way. We're going to say, what does the other denominator have that this one does not have? So this has an x plus 6. This already has an x plus 6. The x minus 1, we know it has. X minus 2. So this has an x minus 2, but this one doesn't. That's what we multiply by. Okay, so what does the other denominator have that this one doesn't? The other denominator had an x plus 6. It didn't. It had an x minus 1. This one did not. When we go to this denominator, the other one had an x plus 6. This one did. The other one had an x minus 2. This one didn't. So that's what we multiply by. Okay. So now we're going to multiply our fractions. So we have x plus 1 times x minus 1. That gives us an x squared minus 1. Don't multiply the bottoms. Okay, 2 reasons. First reason for not multiplying the bottom is there's no reason to multiply the bottom, okay? There's nothing to gain, and we're talking about a cubic because we have 3 factors here, okay? So that just makes our life much harder. But even more than that, the other reason is that eventually we're going to try and factor and reduce. So why multiply something that we're just going to factor at the end? Okay. So x plus 1 times x minus 1, difference of squares. So we got x squared minus 1. Here we have to go through and we have to do distribute. So we get plus x squared. Then we have a minus 2x minus 3x, so minus 5x. And then plus 6. X minus 1, x plus 6, x minus 2. I would include this step, okay? Even though it's a lot of writing, I know it's a lot of writing, even though it's a lot of writing, you want to include it so that you don't make any mistakes in your addition, okay? You don't want to be multiplying and adding at the same time. So now you don't have to write it as one fraction, okay? We, just like here, we didn't write it as one fraction, we just added the numerators from here. So if we do that, x squared plus x squared is 2x squared. Then we have a minus 5x. And negative 1 plus 6 is plus 5. So we want to find the common denominator. The first thing that we did here. Second thing that we did here was we distributed. Essentially what this means is that we're rewriting our fractions with a common denominator. The order in which we do things is always going to be the same here. And it's always going to be the same 4 things. Third thing that we did here is we added the numerators. If it were a subtraction problem, we would be subtracting the numerators. And then the fourth thing that we would do is try to reduce, okay? So we would be looking, is this factorable? And 2x squared minus 5x plus 5 is not factorable. If we use that multiply a times c method, okay, that we've done a few times this semester already, 2 times 5 is 10. So we need two numbers that multiply to 10 but add to 5. And there are no numbers that multiply to 10 and add to 5. So we're checking to see if we can reduce by factoring. The denominator is going to be factored already. That's why we don't multiply it out. But in this particular case, it's not factorable. So we can't do anything. This is our final answer. Okay, and that'll be what happens most of the time. Not always, but most of the time. So you still always have to do this step 4, but a lot of times it's not even going to be necessary. Okay? Okay, let's take another example. Uh, 3 over x plus 1 plus 4 times x squared minus 1. Okay, and we're going to do an extra step here, which may or may not be necessary for some of you. If you notice, here we have an x plus 1, and then here we have an x squared minus 1. So we have to see, how do we get a common denominator? Because it's not common right now. But x squared minus 1 is factorable. So if it's factorable, factor it, because that'll help you find a common denominator. So that's kind of the caveat to step 1, is that sometimes it might take 2 steps because you might be able to factor. Okay, so let's just rewrite these fractions in that way. So the 3 over x plus 1 we can't do anything with. But x squared minus 1 is the same thing as x plus 1 times x minus 1. So this is factorable. So factor it to help you find the common denominator. A lot of times this won't be necessary, but here it was. Okay, and again, you might be able to skip that step because you might know, hey, x squared minus 1 is a difference of squares, and I know x plus 1 is one of those factors, so x minus 1 is the other, and you might be able to just know that what you're going to multiply this fraction by. So remember, you're asking, what does the other denominator have that this one doesn't? And the other denominator has an x minus 1. So that's what we're going to multiply by here. X minus 1 over x minus 1. Sometimes you won't have to do that with both denominators. So here, we're over here. What does the other denominator have that this one doesn't? Nothing. The other denominator has an x plus 1, but this one already has it. So you don't have to multiply by anything, okay? So this denominator already has everything the other denominator has. So we don't have to multiply by anything. So now we're just going to distribute. Okay, everything else is the same. The only thing that changed was we had to factor this in the beginning. So here, again, I'm going to do this extra step. We have 3x minus 3 over x plus 1 times x minus 1. Now, if you wrote x squared minus 1, you wouldn't get any points off. It just means that you have to be careful at the very end in the next step that you can't reduce. Okay, so in other words, what we're saying is the denominator doesn't have to stay factored. You're just not doing yourself any favors by multiplying it out. You're not helping yourself in any way. So now we have 3x minus 3 plus 4. When we combine like terms, negative 3 plus 4 is 1. So we're just left with 3x plus 1 over x plus 1 times x minus 1. There's nothing to reduce here, so this is our final answer. Okay, let's do a few more, and then we'll move on. So let's do x plus 6 over x plus 8 times x plus 9. And this time, let's subtract x minus 7 over x plus 1 times x plus 9. So the process is the same. We want to find a common denominator. So we say, what does the other denominator have that this one doesn't? Well, we just go through the other denominator and we check. This has an x plus 1. This doesn't. So we know we're going to have to multiply by an x plus 1. Let's keep going and just double check there's nothing else that we have to multiply by. The next thing that we see here is an x plus 9. This one already has 1, so we don't have to multiply by x plus 9. So that means that this first fraction is being multiplied by x plus 1 over x plus 1. Now let's do the second fraction. What does the other denominator have that this one doesn't? Well, this has an x plus 8, but this one doesn't. So that's what we need to multiply by. This has an x plus 9. This one does. So we don't need to multiply by an x plus 9 again. So this one gets multiplied by x plus 8 over x plus 8. Okay, so now we multiply. Okay, so x plus 1 times x plus 6 gives us x squared plus 7x plus 6. Then we have x plus 1 times x plus 8 times x plus 9. Now we're going to subtract x minus 7 times x plus 8. This is x squared plus x minus 56. X plus 1 times x plus 8 times x plus 9. Notice the order of the denominator changed. I just did that so that you can see that it's exactly the same. Remember, it's okay. This is all multiplication and it's commutative, so you can change the order. Okay, if I ever multiply incorrectly in a video, just send me an email and let me know that you think I multiplied it incorrectly, because it will happen sometimes. And I can just put a note up on Blackboard and, with that video that says at minute so-and-so I multiplied it incorrectly. Okay, so now we're subtracting. So again, I'm going to put in an extra step. You do not need to put in this extra step. I'm doing it because I know that sometimes it's easy to make a mistake here. This minus sign has to be distributed. So it's one extra step that you'll have to do when you subtract. You do not have to put in this step. It depends on how comfortable you are with your subtraction. Okay, so when you subtract, you have to distribute your minus sign to that second fraction. And remember, it only goes to the numerator. Changing the size of the pieces. And then we just combine like terms here. So x squared minus x squared, the x squareds cancel, so that's kind of nice. 7x minus x is 6x, and then 6 plus 56 is 62. And you should always check to see if you can reduce your fraction. Here we can't if 62 is not divisible by 6. So, and the reason why I say that is you can't factor out a 6 from here and just get an x, which is what you would need in order to cancel out an x plus 1 or an x plus 8 or an x plus 9. We can factor out a 3 here. We can factor out a 2 here, but we're not going to even bother doing that because there's no point. The only purpose to factoring is to reduce. And if we factor and we can't reduce, we don't have to factor, okay? So if we factor and we can't reduce, the factoring is unnecessary. Let's take another example. And I always have extra examples, so if you want some extra examples, you can always send me an email and ask. So this one is a little bit different because it's not coming factored to you already. So we have x squared plus 7x plus 12 in the bottom, x squared plus 6x plus 8 in the numerator. And this is going to be a subtraction problem again. X squared plus 3x minus 54 over x squared minus x minus 30. Okay? This looks so much more complicated, right? Because we have these quadratics, nothing is factored. So this is a case where you want to factor everything first. Always factor first. The reason for factoring is that you may be able to reduce. And it's going to make finding common denominator much easier. Okay. So even if you can't, and most of the time you will be able to, even if you can't reduce, finding your common denominator is going to be much, much easier. Okay. So x squared plus 6x plus 8. I'm not going to go through the factoring. At this point, you should be able to factor pretty well on your own. This is also a great time for you to pause the video and try doing all of this by yourself. So here, you have x plus 4 times x plus 2. The bottom factors to x plus 4 times x plus 3. And then we have x plus 9, x minus 6 on the top in the second fraction. And on bottom, we have x plus 5 times x minus 6. And this is why we factor, because what you can see here is that in the first fraction, x plus 4 goes away. And in the second fraction, x minus 6 goes away. So we actually have a much easier problem than we anticipated. Okay, this problem, instead of being quadratics, is just two rational expressions, each one with something linear. So we have x plus 2 over x plus 3 minus x plus 9 over x plus 5. So without factoring, this becomes a much harder problem. You can see, you can cancel. Okay, so now we're just going to do our multiplication. We're going to figure out what does the other fraction have. So the other fraction has an x plus 5. This one doesn't. So that's why you're going to multiply this by x plus 5 over x plus 5. This one, you multiply by x plus 3 over x plus 3. And then we just do the distribution. So we have to multiply x plus 5 times x plus 2 in this one. Don't skip this step, okay? Do not skip this step. You can skip the step where you distribute and you write it as one big numerator. That's a step that you can skip. You cannot skip this step here where you're actually doing the multiplication, okay? If you do, you are asking for a mistake. You're saying, please, please let me make a mistake, because you will. So x plus 5 times x plus 2 is x squared plus 7x plus 10. You can even combine the next two steps where then you write it as one fraction. I wouldn't recommend it, but you can. So x plus 5 times x plus 3. And then we have minus x plus 9 times x plus 3 is x squared plus 12x plus 27. And then this is where you would distribute the minus sign. So again, I'm going to do this next step. You can skip it in terms of you can skip it in terms of writing it as one fraction, not in terms of distributing the minus. You have to distribute that minus sign. So what we get here is x squared plus 7x plus 10 minus x squared minus 12x minus 27 over x plus 5 times x plus 3. And now we're just combining like terms. So x squared minus x squared goes away. 7x minus 12x is negative 5x. And 10x minus 27 is negative 17. And that's it. We're done. Nothing else to do here. Okay. Okay. We're going to do one more. Okay. One more. Let's say that we have x squared plus 5x plus 6. This is a 5. Okay. Over 2x squared plus 4x minus 6. And then plus x squared plus 6x minus 16. Over x squared minus 3x plus 2. Okay, so this is another case where we're going to want to factor everything. Just a quick note here. And again, I encourage you to pause the tape and do this on your own. Okay. Quick note, as we look to factor each of these, we can see that this has an a of 2. Look to see if you can factor it out, and we can. So this, if we factor out the 2, then we're left with x squared plus 2x minus 3. So when we actually go and factor this denominator, we're going to keep a 2 out here, and we're going to factor the x squared plus 2x minus 3. Okay, just to make our factoring easier, because then we don't have an a value. And it means that even if we factor with this a value, we're going to be able to factor out a 2 at the end, and you can't forget about that. Okay. So if we factor x squared plus 5x plus 6, we get x plus 5. Sorry, x plus 3 times x plus 2. Then on the bottom we have a 2. And then an x squared plus 2x minus 3 factors to x plus 3 times x minus 1. X squared plus 6x minus 16 is x plus 8, x minus 2. And x squared minus 3x plus 2 is x minus 2, x minus 1. And you can see here that we can cancel. If you don't do this, if you don't cancel, okay, then what's happening is you're going to wind up having to multiply cubics in the numerators, okay? And nobody's asking you to do that. I am not going to be asking you to do that. There is a note, though. You can cannot cancel once you're in this step of finding your common denominators. You can only cancel before you find your common denominators, or at the very, very end in the last step. Reason why is if you cancel over here, like this x plus 5 over x plus 5 and x plus 3 over x plus 3, think about what's happening. You're going back a step, right? Then you're undoing the step of finding your common denominator. So make sure that you understand you can only cancel before you find the common denominator, or at the very end when you're reducing your final answer. So we'll write that down in a second, but I want you to be aware of that. We haven't started finding our common denominator yet, so we can cancel here because we haven't started that step. Okay. So now let's go through and rewrite these fractions. Hopefully we'll have enough room here. We have x plus 2 over 2 times x minus 1. And then we have plus x plus 8 over x minus 1. Okay. So now we can start trying to find a common denominator. So we're going to say, what does the other denominator have that this one doesn't? Well, the other denominator has an x minus 1, and this one already has that. So we don't have to multiply this by anything. The other denominator is already included in this. Now we're going to do the same thing. The other denominator has an x minus 1. This one has it. The other denominator also has a 2, and this one doesn't. So we need to multiply by 2 over 2. Notice you wouldn't cancel the 2's here. It wouldn't make sense to cancel the 2's. You would be undoing your common denominator. Then you distribute. So we have x plus 2 over 2 times x minus 1 plus 2x plus 16 over 2 times x minus 1. And if we add these together, we get 3x plus 18 over 2 times x minus 1. And 3x plus 18 can be factored, but we're not going to factor it because it's not going to help us reduce, okay? So let's just write down that other thing that we said. I'll do it over here. You can only cancel before finding your common denominator, or at the very end when reducing. The final answer. So in other words, you cannot cancel here, but you can cancel here because we haven't started asking about the other denominator yet. Okay. And this is important because this is a very typical mistake that I see people make. I see people consistently finding canceling out after they started going through this step, and then they're undoing the work that they did. You shouldn't be undoing any work that you've done. Okay, so I'm going to end here. I'm actually going to end this video here, and I'm going to do another one for you a little bit later. And this one, it's going to be the last piece of work that we have with operations on fractions. And it's going to put all of this stuff that we've talked about together. And then we're going to look at equations with rational expressions. So that's it for today, for this lecture at least.